All right, everybody, welcome to the video here for lesson number 9. So today in class we learned how to factor by grouping. Grouping, we notice, is always going to be 4 terms or more, and we always want an even number of terms. So we can have evenly spaced out groups. So the first thing we want to do is make our groups. So 4 terms tells us 2 groups. If we take the GCF of the first 2 terms, we get x squared, leaving us with x minus 6. GCF of the second 2 terms is negative 25, which also leaves us with x minus 6. This is a good thing because now we see that we have a like term, so we can take that x minus 6 out like a GCF, and we'd be left with x squared minus 25, which is still factorable. Remember, you want to keep asking yourself, can I still factor until there's nothing left to factor? You know that there's nothing left to factor if nothing's factorable, or if everything is a linear product. Right? Each one of those is a linear expression. Let's check out the next one. So if we break this up, x squared, leaving us with 3x minus 5. Here we're going to wind up having negative 16, which also leaves us with 3x minus 5. So that's going to give us 3x minus 5. That's the GCF, and an x squared minus 16. Still factorable, difference of 2 squares again. Right, so you notice all these different factoring methods we've gone over are just going to keep kind of popping up here within these bigger factor completely questions. So you want to just be careful. Moving right along. Sometimes we could do this with quartic polynomials like this next one. Right, so we get x cubed as my GCF here. Leave me with x minus 4. We'll get a plus 4x. Leaving us with a x minus 4. So we're going to get x cubed plus 4x and x minus 4 as my 2 factors. All right? So now we can look for GCF. We can look for sum or difference of 2 cubes, anything like that. I see a GCF here. So I take out an x, leaving me with x squared plus 4 and x minus 4. No, you cannot factor x squared plus 4. I think we talked about that in class, I'm sure, either today or another day, right? Make sure that we're not factoring sum of 2 squares. That doesn't make sense. It's not a factoring method, so keep that in mind. All right, let's keep going here. Moving right along. See, 2x squared is my GCF there, leaving me with 2x plus 1, negative 18, leaving me with 2x plus 1. So we wind up having 2x squared minus 18, which has a GCF, which we'll have to take care of, right? So we have a 2, leave me with x squared minus 9, right? Look for GCFs first. That's our order, right? And we can still do difference of 2 squares, so we can factor yet one more time. Oh, one of those has to be a minus. And we're good to go. Number 2 says, explain why this can't be factored using grouping. So let's try and group it. X squared, leaving me with x plus 3, plus 2x, or 2, would leave me with negative x plus 3. So the reason why, these are not like terms. So we have no like terms, or GCF, whatever you want to call it, same thing. All right, moving right along. So with these expressions that have x's and y's, we want to make sure everything's ordered correctly. So it should go x's with highest exponent all the way down, and then y's with the highest exponent should end. So as the x's go down in exponent, the y should go up in exponent. That happens here, so we shouldn't have to reorder, but we'll see. So what is my GCF here? It's going to be x squared, leaving me with 6x minus 5y. GCF here is going to become negative 4y squared, which is going to leave me with 6x minus 5y. Good, we have a matching pair. So we could say we have x squared minus 4y squared. That can be factored. And 6x minus 5, that cannot be factored. Now the reason why I know this first parenthesis can be factored is it's a difference, perfect squares, so I can make a difference of 2 squares. So x plus 2y and x minus 2y. And this 6x minus 5y just comes down. All right, taking a look at this next one, right? Resist the urge to combine like terms. I know you want to. You see them, and you want to do it really badly. But if you just do grouping here, you won't wind up having an odd number of terms, which would be hard to do. And if you do the grouping method, right, we wind up having like parentheses or like terms. All right, look at that. Now, how did I know to group it into 3 groups of 2 instead of 2 groups of 3? Is I looked at where my exponents kind of stayed the same. If I wasn't sure and you did it in 2 groups of 3, you'll notice you don't get a GCF. So what do you have here? Frozen. So we wind up having x minus 3, x squared minus 6x plus 8. That trinomial can be factored, right? What multiplies to make 8, but adds to make negative 6. That would be negative 4, negative 2. So we could say x minus 3, x minus 4, x minus 2. And we have one last one. So if we take a look here, we have 6 terms. So again, we could go 2, 2, and 2. But if you look, if I did 2, 2, and 2, these middle two have the same exponents. They're like terms. It just is weird. So I'd probably more likely go 3 and 3. Look at the first 3 terms. GCF is x squared, leaving me with 2x squared minus 7x minus 15. GCF here is negative 4, leaving me with 2x squared minus 7x minus 15. Do a little work here. So we have 2x squared minus 7x minus 15. That's my like term. And x squared minus 4. Both of which are factorable. Let's do the harder one first, the AC method. Well, multiplies to make negative 30, but adds to make negative 7. That would be negative 10 and 3. So now if I do 2x squared minus 10x plus 3x minus 15, group it. So we have x, 2x, sorry. So we have x minus 5 and 3, x minus 5. My two factors here are 2x plus 3 and x minus 5. X squared minus 4 is going to be x plus 2 and x minus 2. There you go. This would be about as difficult as I would give you on a quiz or a test. Hopefully this all helped, all right? And you're doing your homework, watching these videos will help, all right? Good luck with everything, and I will see you tomorrow in class. Have a good night. Good night.